Yes. Good morning to you all. Okay. So, good morning to you all. Let's think about the chapter Morphology of Flowering Plants. So, I think we have started to study something about the morphology of flowering plants, about the stem systems, and also about something that we know, modification of stem, root, and the modification of the root. Okay, and the next part is the main part, isn't it? We all have, I think you are eagerly waiting, or you know that the next part is the main part of the plant itself, that is the leaf. Okay. So, when we are thinking about leaves, we will think that what is the peculiarity of the leaf, isn't it? Okay, what all are the uses of this leaf, isn't it? So the leaf is a lateral, generally flattened structure borne on the stem. Okay, leaf is lateral. Okay, leaf is lateral, generally flattened structure. Leaf is lateral, generally flattened structure. Okay, borne on the stem. Borne on the stem. So leaf is generally lateral, flattened structure which is borne on the stem. Okay, so it develops. What is the speciality of that? It develops at the node. Okay. It develops at the node. Okay, and it develops at the node and bears a bud. Bears a budding axil. It didn't complete it. Okay, bears a budding axil. Okay, so it develops at the node and bears a budding axil. Okay, the axillary bud. Okay, the axillary bud later it develops into a branch. The axillary bud which will later develops into a branch. Okay, and the leaves originate from shoot apical. Okay, leaves which will develop from shoot apical meristems. Okay, it will develop from or originate from shoot apical meristems. Okay, shoot apical meristems. Okay, leaves develop from shoot apical meristems. Okay, and are arranged in an and are arranged in an acropetal order. Okay, so what we have said about the leaf is a lateral, generally flattened structure is born on the stem, and it develops at the node and bears a bud in its axil. The axillary bud later develops into a branch. Leaves originate from shoot apical meristems and are arranged in an acropetal order. They are the most important vegetative organs for the photosynthesis. Okay? Yes. Okay, now you acropetal order. Okay, now you guys, after that we will say about the next things about the leaf. Okay, now you write this. Okay, so we are next going to study about a leaf. Okay. Okay, so they are the most important vegetative organs for photosynthesis. Okay, vegetative organs for vegetative organs for photosynthesis. Okay, and a typical leaf contains 3 parts. Okay, mainly 3 parts it contains. Okay, which all are the 3 parts? Yes, the leaf base, the leaf base. Second one, the petiole, and third one is the lamina. Okay, leaf base, petiole and lamina. The leaf is attached to the stem. Okay, the leaf is attached to the stem by leaf base. Okay, so and may bear 2 lateral small leaf-like structures called stipules. That means 2 leaf-like structures. Okay, leaf base, that is leaf attached to stem. There will be 2 leaf-like structures, that is known as the stipules. Okay, so in monocotyledons, when we are saying about monocotyledons, in case of monocotyledons, the leaf base expands into a sheath. Okay, leaf base expands into sheath. Okay, leaf base in monocotyledons, leaf base will expands into sheath. Okay, so it will cover the stem partially or wholly. Okay, it will cover the stem okay. So in some leguminous plants, in case of some, we are seeing about full this leaf base. Okay, so in case of leguminous plants, the leaf base may become swollen, which is called as the pulvinous. Okay, in leguminous plants, in case of leguminous plants, what will happen? In case of leguminous plants, the leaf base may become swollen. It is known as the pulvinous. Okay, it is known as the pulvinous. Okay, and the petiole help hold the blade to light. Okay, and the petiole which will help in the hold the blade to light. Hold the blade to light. Okay, so what we have said, yes, it is the vegetative organ for the stem, isn't it? So the axillary or the leaf is the most important vegetative organ for the photosynthesis, and a typical leaf consists of 3 main parts, that is leaf base, petiole and lamina. So in case of leaf base, we have said that it is the leaf is attached to the stem by using the leaf base and may bear 2 lateral small leaf-like structures, which is called as the stipules. Okay, and in case of monocotyledons, the leaf base expands into sheath. Okay, expands into sheath, covering, yes, it will cover the stem partially or whole. In some leguminous plants, in case of some leguminous plants, the leaf base may become swollen. leaf base become swollen. It is known as the pulvinus. And next we have to say about the petiole. And when we are saying the petiole, it holds the blade to the light. It will help to hold the blade to light. Okay. Now you write that. in the last section we are going to study. Okay. Okay, so the next thing is the petiole help hold the blade to light, and long, thin, flexible petioles long, thin, flexible petioles. Okay, long, thin, flexible petioles allow leaf blades to leaf blades to flutter in wind. Okay, flutter in wind. It will help to flutter in wind. Okay, thereby cooling the leaf and bringing fresh air to leaf surface. Okay, cooling the leaf and fresh air to leaf surface. Fresh air to leaf surface. Okay, and the lamina or the leaf blade. Okay, the lamina or leaf blade. Okay, the lamina or leaf blade is green, expanded part of the leaf with veins and veinlets. Okay, it will expand it to make the veins and veinlets. Okay, so there is usually a middle prominent vein. Okay, there will be a middle prominent vein which is called as the mid-rib. Okay, mid-rib. Okay, and these veins provide rigidity to leaf. Okay, veins provide rigidity and also rigidity to the leaf blade and act as channels of transport of water, minerals and food materials. Okay, rigidity and make channels for transport of water, minerals and food materials. Okay, so the shape, margin, apex, surface and extent of inclusion of lamina varies in different leaves. Okay, the shape, margin, apex, surface and extent of inclusion of lamina varies in different leaves. Okay, so I think you have understood. So long, thin, flexible petioles allow leaf blades to flutter in wind, and cooling the leaf, okay, will cool the leaf and bring fresh air to leaf surface. And the lamina or the leaf blade is green, expanded part of the leaf with veins and veinlets. And there is usually a middle prominent vein which is known as the midrib. And veins provide rigidity to the leaf blade and act as a channels for transport for water, minerals and food materials. Then the shape, margin, apex, surface and extent of incision of lamina varies in different leaves. Okay, that's about leaf. Okay, so I think we have now we have time to conclude the class. So I think you now get it, what is a leaf and what is function of a leaf. So now we will conclude the section. We will get into the section of venation in the case of leaf in the next class. So in the next Monday. So thank you for listening to this class. Write those notes, and after 5 minutes I will conclude this class. So thank you for listening to this class. Stay home, stay safe.